Okay, welcome to worksheet 2 for chapter 6. So today you're going to learn about linear functions, okay? You're going to learn how to draw a graph today. But let's explore some of the definition clearer first, okay? In many problems, we often investigate the relationship between two variables, okay? So there are many maths or rather math or non-math situation is always measuring the relationship between two things, like if one increase, what happened to the other? If I change this value, how would it react? Okay, so the moment you start exploring such possibility, you're actually looking at two different variables, two things that can change. I think you have done that in science also. One method to obtain the values, corresponding values. Now the words corresponding means that it's a pair. The change in x will directly result the change in y in some value. So a certain value of x is paired with a certain value of y. So we call it the corresponding. And then we will plot them as an ordered pair, bracket x, y, on a Cartesian plane. Cartesian plane is in this boxy form, okay? The graph paper, basically, we call it Cartesian plane. Okay, so for example, what you see here are 0, 0. Okay, this is 0, 0. This, you write down together with me. Okay, this coordinate is your 1, 2, 2, 4, 3, 6, and 4, 8. So these are some of the coordinates that's being plotted on the Cartesian plane. You see the cross here? The cross here means that we plot them, okay, on the Cartesian plane. Does it mean that if I plot here, there's no value? Does it mean that I cannot plot here? It's no value? No, it's not true. It just simply means that I have chosen to plot 1, 2, 3, 4, 5 points on the graph. Okay, so now looking at this, okay, can you tell me what is the relationship between the y coordinate and the x coordinate? Can you tell me the relationship between them, between the x and the y, by looking at these points here? Okay, explain or describe it mathematically as much as possible. Okay, so what it says is this: as x coordinates increases by 1, okay, see my x value, because remember the first number is x, second number is your y. As my x increased by 1, the y coordinate increases by 2. Every time x plus 1, my y will plus 2. So that's a relationship between them. Okay, you can pause the video, go back and look at the number and think through again if you need to. Yeah, so these variables are connected. The variables here referring to your x and your y, they are connected in a direct proportionality manner, meaning that they have a linear relationship. Linear comes from the word line. Okay, it comes from the word line, meaning that the relationship can be drawn onto a straight line, just like what we have over here. Okay, if you plot the points and connect them, you realize that you will get one straight line. It is not always the case. Sometimes in your previous worksheet, you have seen that you can get a curve, you can get a C shape, you can get a U shape, or any other shape. But the relationship here, we can see that they are connected by a straight line, and therefore we call this a linear relationship. And this linear relationship is in this case that when x increased by 1, y increased by 2, and what does it mean? This is what it means. Okay, this equation that we see here is y equals to 2x. Okay, this is for the graph that you see on both. Y equals to 2x because as x increased by 1, I take it times 2. Okay, This is one of the ways that we can describe this. So we call these straight lines in the equation, okay? Straight line in the graph of the equation y equals to 2x. So such straight line graph, we call it linear equations. And okay, any points on the line will satisfy the equation y equals to 2x. Meaning that as long, okay, any points on the line that will satisfy, as long as I can plot a point that lies on this line, then I will say that this point is a correct point, okay, because it is valid for this equation. Let's answer the questions below here. Question 1. States the coordinate of a point other than those given which lies on the line y equals to 2x. Are there any point? You can state anything, you don't have to state what I have written. You can try first. Choose any point you want. Okay, I am going to pick this. What is this point? Right, this point, if I measure down, my x value here is 0.6 and my y value is double of it, so it is 1.2. Okay, so you can see that this is 1.2. You can count, right? Every small box is 0.4, 0.4 and 0.4, 0.8 here. Okay, I hope you can see. And therefore it's 1.2, then followed by 1.6 and become 2. So therefore, one of the point that I can find here is 0.6, 1.2. So this is one other point. Second point, does the point 2.5, 8 lies on the line y equals to 2x? Why? Does this lie on the line? Now let's go back to the graph. Okay, I'm going to erase everything because it's a bit crowded really. So let's look at the point 2.5. So 2.5 is somewhere here. Remember, we say we can cut the smallest box at most into half. So right here, and I go across. What number do I get? It's 4.4, 4.8. So it is actually 5 here. Correct, if you count properly. So if I take this coordinate, it will be 2.5 and 5. And this is 2.5, 8. Now this point here is wrong because it's not on the line. It doesn't fit. Okay? So I go back to the question here. Does it lie on the line? No. Because when x equals to 2.5, then y equals to 2 bracket 2.5, my y should be equals to 5 instead of 8. Okay, so what do you observe about the value of y as x increases in the graph above? So this one we have mentioned just now already. The value of y increases twice as much as value of x increases. So if x increase 5, y will increase double of that, 10. If x increase 100, y will increase by 200. Okay, so follow the next video for the next part. Okay.